Okay, so today we are going to start with a new topic that is known as the hardware. And hardware is basically containing three different phases. Number one, it's the phase regarding memory and data storage, the first phase that we will be covering today. The second phase is regarding the input and the output devices. And the other phase or the third phase is regarding the computer architecture. Now, when it comes to the memory and data storage, so over here, I have just mentioned a simple definition about the memory that if you're going to store any kind of your data or any kind of the information for your later use, or you need to utilize it afterwards, so that will be termed as a memory. Now, there are four different types of the memory: primary, secondary, tertiary, and the last one is the offline. Primary means a sort of the memory without which your system cannot operate. Any of the thing it cannot operate. That is known as the primary memory. But when it comes to the secondary memory, so these are the types of the storage devices without which your system may operate, but it won't be 100% operational. Okay. And tertiary means an online storage capacity that may include the clouds, drives, and etc. Okay. When it comes to the offline storage, so offline storage is like CDs, DVDs, Blu-ray discs, magnetic discs, USBs, flash drives. These are known as the offline storages. Now we will be discussing about each one of them one after the other. Coming to the primary storage, so over here for the primary storage, I do have mentioned that these are the types of the storage devices, or these are the types of devices without which your system cannot operate at all. So these are known as the primary storage devices. They may include RAM, ROM, registers, cache. Now we will be discussing about each one of them. Starting with the RAM. Now, what is a RAM? Now, it's a random access memory and it's a volatile in nature. Now, what do you mean with a volatile? Volatile is something that is termed as temporary. That means it is being given for a particular time interval, and as soon as you are going to shut down the power or you are going to end up the power backup, so anything that will be present in the RAM, anything that is present in the RAM at that particular moment will be vanished or will be finished off. Am I clear till over here, guys?
Yes, sir.
Okay. Now coming towards the types of the RAM, so we do have three different types of the RAM: SRAM, DRAM, and finally we do have the SDRAM. Static RAM. Number one, static random access memory. Now it's a type of the RAM that does not need to be refreshed again and again for performing a particular task. But on the contrary, when it comes to the DRAM, it's a dynamic RAM and it's a type of the RAM that needs to be refreshed again and again after equal interval of the times. Like for example, if I'm giving you the task and that task is of, for example, 3 minutes, so you will be performing that task in 3 minutes, so that is known as SRAM. But when it comes to the DRAM, so DRAM will be performing that particular 3 minute task in 4 or 5 minutes because it will be taking few of the gaps after equal intervals. Can anyone please let me know that what will be the faster thing? Is it SRAM or is it DRAM? Who's performing it faster? Who is processing the data faster? Sorry, I can't get SRAM, but can you please also let me know that what is which one is having the higher longevity? Which one is having the higher life? SRAM or DRAM? The one which is taking
Yes, sir. Yes.
the DRAM, because the thing that is taking gaps or that is refreshing itself, obviously the life will be more as compared to the SRAM because it's not taking any sort of the gap and it is working continuously. Okay, so the longevity is more with the DRAM, but when it comes to the processing speed or execution speed, that is with the SRAM. Coming towards the SDRAM, am I clear with the previous point?
Yes, sir.
Oh, good. Now coming towards the SDRAM, now what is an SDRAM? SDRAM is something that is a hybrid sort of the RAM and it is containing the features for both SRAM and DRAM. And this is the type of the RAM that we are utilizing in our systems because we are performing for each and every sort of the data. Like for example, we are performing something on Microsoft Word or Microsoft Excel or PowerPoint. So these sort of the files are quite low and these will be termed as the static RAMs. Or these will be processed with the static features. But when it comes to the gaming, so gaming thing is processed by the dynamic feature, so that is known as the, because there are heavy graphics and all, so we need to refresh our RAM so that we can process that quite faster, so that these are known as the these will be performing with the features for the DRAM. So these are the reasons that we are utilizing SDRAMs in our system, so we can perform both of the tasks at a particular intervals. Then it comes to the ROM. ROM is the read-only memory, and it's a non-volatile in nature. Now, what do you mean by the non-volatile? It means permanent in nature. That means anything that you're going to store in RAM will be stored completely or will be stored permanently into the ROM. Now, when it comes to the types of the ROM, so we do have multiple types of the ROM over here. Number one, it's PROM, then it's EPROM, and finally we do have double EPROMs. Now, what do you mean by that? PROM is something that's a programmable read-only memory. That means it can only be reprogrammed once. It cannot be reprogrammed again and again. But when it comes to the EPROM, so these are the types of the ROM that can be reprogrammed again and again. Sorry. Now these are the types of the ROM that can be reprogrammed again and again. But to reprogram this type of the ROM, we do require an ultraviolet light, and obviously we cannot operate with an ultraviolet light in an open environment. We do require a lab environment as well to perform these things. Coming towards the EEPROM, it's an electronically erasable programming read-only memory. That means a type of a ROM that needs to be reprogrammed or that can be reprogrammed again and again. But to reprogram, we do just require certain softwares to reprogram it, and that is known as EEPROMs. Am I clear till over here, guys?
Yes, sir.
Yes, sir.
Okay. Now, I was utilizing a word reprogram again and again. Now, what do you mean by that terminology reprogram? Now, just try to understand when it comes to the ROM. So, sorry, when it comes to the RAM. So, might be you guys have seen a RAM physically. It's just like in the form of a scale or something like that. Okay. But when it comes to the ROM, so you cannot see that thing physically because it's built in with the microprocessor. So for these sort of the things, we do have the schematic, or you may call it the schematic as well, diagrams. That means these are the structural diagrams of those things. Then how do they look? So I do have mentioned over here the horizontal lines as the data lines and the vertical lines as the address lines. Now these are the semiconductor diodes, and let me zoom in for you guys. There are dots at both ends. These dots basically represent that this particular data of this address should be fetched for execution. These are the gates. They will be applying, they will be giving you the data or the addresses. Okay. And there, when we were talking about reprograms, basically we were changing the location of these semiconductor diodes, because as we're going to change with the location of these semiconductor diodes, so obviously the data and the address will also be changed, and obviously the execution thing will also be changed. Is it clear till over here? Any issues?
No.
Both of you clear? Okay.
Yes, sir.
Yes, sir.
Okay, now we're moving ahead towards the memory pyramid. Now, what is a memory pyramid? Memory pyramid is something that we are telling about particular memories over here. At the peak or at the top, you may see I have mentioned a microprocessor over here. Then the nearest thing to the microprocessor is the cache. These are somewhat similar to the RAM. They are volatile in nature, and they are containing a very less amount of the file or very limited file, mostly the file that are currently being processed. Then we do have the registers. We will be just dealing with the registers in detail after this topic. Then we do have this RAM. We discussed about this as well. And then we do have the secondary storage devices. We will be dealing with them as well. Now there is an arrow, that's an upside arrow. This upside arrow represents, what does it represent now? There is a note placed over here. It says, as you move to the peak or as you move to the top, so the cost increases, because it's quite easily understandable that if you're going to find in Pakistani rupees, if you're going to find a 500 GB of the hard disk drive HDD, so you may find it around approximately for 2,500 or 3,000 rupees. But when we are going to find a 4 GB of the RAM, you see at one place it was 500 GB, and at the other end it's just a 4 GB of the RAM. And this 4 GB of the RAM cost approximately the same as of the 500 GB. So as we are moving up, that means the cost increases, while the access time, that means the time to reach the processor, is gonna decrease, as well as the storage capacity is also gonna decrease. Storage capacity you can find on the secondary storage device easily in the TBs, terabytes. When it comes to the RAM, so you can find them easily in the GBs. Then registers are mostly in the MBs, and when it comes to the caches, so they are mostly in the MBs or KBs. So as we are moving up to the top, so we are reducing with the storage capacity as well. Then we do come with the registers. What are the registers? Just like RAM, registers are also volatile in nature. That means they are also temporary in memory, as we are going to shut down the power. Anything that is stored in the RAM will, anything stored in the RAM will also be lost. I mentioned over here that in general there are 14 types of the registers. Now, what does this sentence means over here? This means these registers can also be classified or simplified into further sort of the data. And if they are classified into the further sort of the data, so we will say that there are 14 types of the registers. Now, few of them we have mentioned over here: general purpose, accumulator, MAR, memory address register, MBR or MDR, memory buffer or memory data register, CIR, current instruction register or instruction register, input register, output register, and finally we do have the status register. Now we will be dealing with each and every one by one. So a general purpose register is a type of a register that acts as a waiting area. Waiting area for what? If any data is coming for the execution, the processor is not free at the time, so the data is going to wait in the general purpose register. Similarly, if the data has been executed and it needs to go to a particular memory location, but there is nothing or no bus is available to carry that data to that particular memory location, so again that data is going to wait in the general purpose register. When it comes to the types of the general purpose register, so we do have 4 types: AX, AX, BX, CX, and DX. Okay. Now, what do you mean by the X? Like I mentioned a complete byte over here, it's 10010010. Now, if I need to represent a complete byte in an assembly language, or you may say in the language of the processor, they will be represented by a X, or it will be represented by an X. But if I just need to work on the 4 nibbles, the first initial 4 nibbles are known as the high bits, and the last or the low bits, the last 4 nibbles are known as the low bits. So if I need to represent a complete byte, I will be represented by an X. But if I need to represent just the high bits or the low bits, so I will be representing it by an H and L. Am I clear till this point?
Yes.
Okay. Now we're coming to the memory address register. Now this register is basically containing the address of that particular location from where you need to fetch the data for execution, or where you need to fetch the data after execution. Execution से पहले data कहाँ से लेकर आना है, और execution के बाद data को ले जाके कहाँ पे store कराना है. Those particular locations are basically termed as, or those particular location addresses are basically stored in MAR. Then it comes with the MBR, memory buffer register, or you may call it as the memory data register as well. Now, these are the registers that will contain that particular data whose address was present in MAR. CIR, the current instruction register, or you may call it as the instruction register as well, will contain that particular instruction, that what instruction you need to apply it on the data that is present in MBR or MDR. Whether you need to apply a arithmetic operation or a logical operation, whatever the sort of the instruction you need to apply over that. Program counter. Program counter contains the address of the very next data that needs to be fetched. For example, right now I'm dealing with the O levels. I'm dealing with the O levels right now. So the address of this O levels will be in MAR. But after this, I need to teach, for example, AS level. So this address will be present in the program counter, the address of the very next instruction that needs to be fetched. Then we do have the input register and the output register. These simply contains the data that is coming as an input from any peripheral device, or output thing contains any sort of the data that is going out. We do have the accumulator as well. Now the accumulator register is basically responsible to perform all the arithmetic and logical operations. Now it may include plus symbol, minus symbol, modulus, or multiplication, division. These all are the arithmetic operations. For the logical, less than, greater than, equal to, not equal to, less than, equal to, greater than, equal to. These all are the sort of the logical operation, and that is the responsibility of an accumulator register to perform all these sort of the things. We are coming to the status register. Status register defines about the current status of your data with the help of few flag registers. For example, if I perform any kind of the calculation and I'm getting 0 as an answer, so that will be represented by a 0 flag register. Similarly, I'm performing any kind of the task, and after that, after performing a particular task, I'm getting a carry. That means just some simple, for example, I'm just performing a calculation 1 plus 12 plus you may say 19. So this will give a carry to me, 11 and 1 carry. So if I'm getting a carry over here in any sort of the calculation, so that will be represented by the carry flag. Sign flag informs us about the positive or negative symbol of a number, whether it's a positively signed or a negatively signed. If it's positively signed, so it's a 1. And if it's, sorry. If it's positively signed, so it's a 0. And if it's negatively signed, so that is represented by a 1. So that will be represented by the sign flag. We discussed about the parity in the last class. So if we are having an odd parity or even parity, that is also represented by a parity flag register. Am I clear till over here with the register thing?
Yes, sir.
Okay. Now this is the thing I mentioned this all as well. You can take it afterwards and you can just copy this down. I hope so that for the previous recordings, you guys have copied the things as well. Now we are coming to the, have you guys copied that? Arva, Sheena?
Yes, sir.
Okay. Now we're coming to the buses. Now what are the buses? Now buses is something I have written over here, set of the electronic wires. Now you might have seen a motherboard. On a motherboard, you might have seen multiple lines that are embossed over it. Those embossed lines are basically termed as the buses. So the set of the electronic wires that carries data or signals from from one component to another component, or you may say a connecting path or a communicating path between different components of a system is termed as a bus. Now there are three types of buses: a data bus, an address bus, and a control bus. Now data bus is basically responsible to carry the data that needs to be transferred from one component to another component, and you may say the address of that particular data is in MAR or is provided by the MAR. Always do remember that when it comes to the data and the control bus, so these both buses are bidirectional, but when it comes to the address bus, so this address bus is a unidirectional. Now for the address bus, I do have mentioned over here, it carries the address of the location from where or to where data is to be fetched. From where you need to bring the data or where you need to take that particular data, that will be termed as an, or that will be the function of the address bus. Control bus is carrying all the operations that are taking place within the system. Am I clear over here, guys?
Yes, sir.
Okay, now I'm just skipping cores and system clock right now. We will be dealing with these things, but afterwards, okay? Now I'm coming towards the compression technique. So when it comes to the compression technique, so always to remember that there are two different kind of compression techniques: a lossy compression technique and a lossless compression technique. Now, what do you mean with lossy compression technique? Lossy compression is something, once you're going to compress the data is not going to return to its original size. Like for example, you might have witnessed that you are clicking any picture from a DSLR, and if you are sending that particular picture with a WhatsApp app, so that picture quality shrinks. And once it has been shrink, now it will not come to the original size. So that is known as a lossy compression technique. But lossless is something that if you are going to shrink any of the data, that can return back to its original size. For example, you may say RAR files. We are making up the WinRAR or the RAR files. So these are basically known as the lossless compression techniques. Am I clear till over here?
Yes, sir.
Now when it comes to the pixels, so what are the pixels? Pixel is the smallest element of an image. Particularly, the smallest element of the image is termed as a pixel. And resolution is something the total number of the pixels present in an image. Whatever the numbers of the pixels are present in the image, that is known as the resolution. Then we come into the dot pitch. Dot pitch is the distance between the pixels. The distance between two consecutive pixels or two successive pixels is known as a dot pitch. Memory conversion, guys need to learn these because they will be quite beneficial for you and you need to do the task regarding these things. So always to remember that 4 bits are equivalent to 1 nibble. Similarly, 8 bits are equivalent to 1 byte. 1024 bytes are equivalent to 1 kilobyte, whereas 1024 kilobytes are equivalent to 1 megabyte. And similarly, 1024 megabytes are equivalent to 1 gigabyte. As CIEs don't allow us to have the calculators with us or to perform any kind of the calculations with the calculator. So they give us an ease, and what's that ease? That instead of 1024, we can consider it as 1000. Obviously, that won't give us the accurate answer, but it would give us the approximate answer. So instead of 1024, we can consider it as a 1000. Clear with this part?
Yes.
Okay, now just give me a second so that I can just move ahead. Okay, so we are continuing over here. I hope so you guys can see the screen. Can you see the new screen?
Yes.
Okay, so we are coming to the next part that is known as the file formats. Now we do have different types of the file formats. Number one, it's an MIDI. Then we do have the MP3. Then we do have MP4. Then JPEG, and finally we do have the text and the number formats. Now, MIDI file means musical instrument digital interface files, and these are the these are the type of the files that do contain just the instrumental or digital instrumental sounds. No lyrics, no videos, nothing apart from the instrumental sounds, just the instrumental sounds they are containing. They do have two additional bytes. And what are those two additional bytes? Number one, it's the pitch byte, and the other one is the velocity byte. The pitch byte and the velocity byte. Pitch byte tells us that which note I need to play. कौन सा वाला sound मुझे play करना है. Whereas the velocity byte tells us the intensity or the amplitude of that particular note, that how loud I should play it or how low should I play it. So this was for the MIDI. Then we do have with the MP3 and MP4 files. These are okay, MP3 files, these are basically the type of the files that are basically containing the instrumental as well as the lyrics in them, and they are the soundtracks. But when it comes to the MPEG-4 files, now MPEG-4 files are basically having the videos in them as well. Finally, we do have the JPEG image files. Now, what are the JPEG image files or the bitmap files or the PNG files? All these sort of the files are basically in pictorial format, or the pictorial format of the data are known as the JPG or PNG or these type of the files. Finally, we do come to the text and the number formats. So Word, Excel, PowerPoint, or Notepad, these sort of the files are known as the text and the number file formats. Now, when it comes to the C and the lossless compression, so all these four contain or are categorized within the lossy compression. Apart from the text and the number format, these are termed as the lossless compression formats. Okay, these are termed as the lossless compression format because anything apart from the text and the number file formats, if you're going to compress, it won't return to its original size. But when it comes to the text and the number file formats, it can easily come back to the original size. That is the reason they are termed as the lossless compression files. Now we are asked with a question that why, it's a past paper question as well. that why picture why picture E is fuzzy as compared to picture A. Yes, guys, any idea? I just told you that why picture E is fuzzy as compared to picture A.
It's a possible. I'm not written situational styles after conclusion.
Can you please repeat yourself? Like I was unable to hear.
Picture E is compressed,
Okay, apart from that,
more pixels,
picture E is fuzzy. Okay, so you may write the answer over here that due to more dot pitch, due to more dot pitch, or you may write the proper wordings over here. Your answer or concept was fine, but I'm just giving you the proper words for that. Okay, due to more dot pitch, or the other answer what you can write over here is due to less number of the pixels or less resolution. Okay, so these could be the answers. Greater than. Now we're coming to another question. What does it say? It says a CD is being used to store music, sorry. Each minute worth of recording is 12 megabytes. Now, each and every single minute is containing or is taking 12 megabytes. Now, they are saying the CD contains 9 tracks, which are the following length in minutes: 3, and then 5, 6, 4, 5, 2, 7, and then double it. How much memory would these 9 tracks occupy? So 1 minute of the recording was taking up 12 megabytes, and they have given multiple tracks over here, and they have given the minutes of these tracks. So now they are saying that how much storage capacity they're gonna occupy. So any idea that how are we gonna do that?
multiply them by 12.
Okay, now we can multiply the individual by 3. Okay, and then we can add them together, or the shortest method what we can do. Your method was fine as well. Okay, we can add, first of all, we can add all the minutes: 3 plus 5 plus 6 plus 4, and then 5, and then 2, and then 7, and then again 8 plus 8. And after addition, just multiply the entire by 3. So as you are not allowed to use the calculator because you are going to give your CIEs, but I am allowed to use the calculator. So what I'm going to do, I'm going to add them all so that it can save us the time as well. 4 plus. Okay, so the final answer that we are getting is 48, and 48 will be multiplied by 3, and we will be getting the answer. I hope so. It's 576. Let's see. Am I getting the answer right? 3 plus 5 is equivalent to 8, then 10, 18, then just after 18, 14. So 18 plus 14, we are going to get 32 plus 16, it's 44. Oh, why I multiplied that by 3? I'm so sorry. We need to multiply by 12 because 1 minute was taking 12 megabytes. So obviously multiple these minutes will be multiplied by 12. So 44, you are getting 48, sorry. 48 is multiplied by 12. And now we will be getting the answer finally. So that's 576. Yeah. 576. And what will be the unit over here? Yes,
Megabytes.
megabyte. Very great. Okay. Ashinamita, is that point clear?
It's a
Okay. Now we come to the part B. Now, what does the part B says? It says if the CD was downloaded to a computer and then all the tracks were put through an MP3 compression algorithm, how much memory would the 9 tracks now occupy? You may assume a 90% file reduction size. Now 576 MBs has been reduced 90%. So how much memory is left? It has been reduced by 90%. So just let me know that if the thing has been reduced 90%, so how much is left? If the thing has been reduced by 90%, what is the percent that is been that's remaining? Just reduce 90% out of 100. Ashina, Arwa, Ashina and Arwa, beta, can you hear me?
Yes, sir.
So if 90% has been reduced out of 100, so obviously 100% is left, guys. What's the matter? So 10% is reduced. So obviously they are saying that 90% has been reduced. So what is the file size that is remaining? So 10% is remaining only. So what we need to do, we can just simply take out the 10% of 576 divided by 100. So it will be 57.6 MBs. Is it clear now?
Yes, sir.
Okay. Now coming to the next part, it says find the average size of each of the MP3 tracks and then estimate how many MP3 files could be stored on 800 megabyte CD. So the total size was 576 with us. To find the average, what we need to do, we need to divide 576 by 9. Why we need to divide 576 by 9? Because it told us that there are 9 tracks in all. So total is divided by the number of the contents. So if you are going to divide 576 by 9, you will be getting 64 as an answer. So that's an average size. Now they are saying that how many tracks of this average size, this 64 average size, could be stored on an 800 megabyte CD. So what you need to do, you just simply need to divide 800 by 64. So you will be getting an answer 12.5 megabyte. Okay. Sorry, no, it's not megabyte. So 12.5. Now, how many tracks are we gonna store? 12.5, 12 or 13? Yes, Ashina, beta, what do you say? 13. Okay, Arba, what do you think?
12.
We will be storing 12 tracks over here because they are saying that we do just have the capacity for 12.5. There is a place only for 12.5. We cannot add additional 0.5 into it. Okay, but we can also not have the half of the song. We need to omit that remaining half as well, and we will be only storing 12. And now you need to see that in which format they have asked the question. They have said how many MP3 files. So you need to write it over here, 12 MP3 files. Got this point?
Yes, sir. Yes, sir.
Okay. Thank you so much, guys, for today. Inshallah, we'll continue it in the next class. Any queries still over?
No, sir.
Okay. Thank you so much, guys. Allah Hafiz.